Okay, before we break for lunch, we will hear from Arun Dogger, Chief Technology Officer at Solfac. Arun has been with Solfac for more than 26 years. His responsibilities range from overseeing research and development activity across Solfac's portfolio and to provide strategic focus to Solfac's technology development and mooring selection for clients' projects. Arun will be sharing with us on the role of digitalization in optimizing turret mooring systems design and operations. Arun will be presenting virtually and we'll be taking questions online after his presentation. Over to you, Arun.
All right, well, thank you very much and good afternoon, everyone. Apologize for not being there in person, but I thought I'd do the next best thing and present it live virtually. I'd just like to acknowledge my co-author who's been working very closely with me in our developments of digitalization on turrets, Yorick Minabo. And then maybe just give you an overview of what my presentation is going to focus on. This is going to be very specific and focusing on our use of digitalization, which also is a good understanding of what everyone else in the turret mooring industry is doing, but specifically to turret mooring. And the focus that I will have today is primarily on asset integrity management, but trying to show how we're tying everything from design all the way through the life cycle. So just as an overview, I'll start by giving you a quick introduction to turret mooring systems, just one slide to explain some of the details for those of you who may not be too familiar. I'll talk a lot about our asset integrity management plan and the life cycle approach that we are taking, and then drill down a little bit into the digitalization efforts and monitoring and inspection, the use of AI, etc., that we have implemented or are in the process of implementing. And then I'll end up with just some final thoughts and conclusions. So in this slide, it's, for those of you who are familiar with turret moorings, it's pretty straightforward. For those of you who are not, let me just try and provide a 1-minute overview. So when you look at a turret mooring system, what makes it different from other mooring systems in general is that it is both a load transfer system and a fluid transfer system. So typically mooring systems are associated with load transfer, but some of the very complex turret designs like the one shown here actually it's really the interface between SURF and the top sides of the vessel. And depending on the optimization between SURF and the top sides can actually play a critical role in the process plant itself and its management. So on the process side of turrets, we've always seen a fairly high level of digitalization, sensors, etc., feeding back to the central control room. We have also implemented a lot of instruments to focus on key components of turrets that I'll show you on the other side. So, there's a number of parts and pieces and equipment on board a turret, but there are really 3 components that distinguish a turret from maybe other topsides equipment or structural equipment on board the vessel. So one is the bearing system and the swivel system. Those are the 2 systems that allow the vessel to weather vane around a fixed position. And the third one is the anchor leg system. You obviously have anchor leg systems on spread moorings, but that's the third part that kind of gives us a turret mooring system. The rest of the components, the piping, the valves, the structures, are very similar to the equipment on board the vessel. And when it comes to design, when it comes to inspection, when it comes to maintenance, a lot of those are quite similar to what you do on board the topsides. So what we found over time is that we really need to emphasize the focus that the operator needs to place on the mooring system, on the swivels and the bearings. And in the past, maybe we have not seen that being taken and looked at with that focus. So looking at what we used to do. So most turret mooring suppliers are both EPC contractors that we tend to design a product that we sell to either an operator or an FPSO provider. And we also work very closely with some of these operators. For example, Sofec works very closely with our parent company MODEC, so that allows us to integrate a lot of our efforts with what they are doing on the entire FPSO. But in the past, a lot of the focus used to be more of an EPC focus. We would get client specifications. The designers would focus on meeting those specifications. Many times we would get very little input from the operations side of the FPSO. And we would end up writing fairly prescriptive inspection and maintenance requirements for our equipment. And so you get a turret mooring system, you train a group of people on the use and inspection of that turret, and you have a very large manual that's provided to the client. And then I'd say 7 out of 10 cases, maybe you're not that involved with the operation of the facility. You may be called to perform inspections, but a lot of times how that O&M, how those prescriptive requirements are actually built into the operation of the FPSO, it may not be that clear to the turret mooring supplier. And that's how things used to be. On the operations side, again, looking at how things used to be, we would see there was a lot of focus on the fluid transfer systems, because that's where the production flowed through. We'd see less on the load transfer and maybe not so much familiarity with the mechanical components of the turret, the bearing, and even the mechanical portions of the swivel. A lot of the communication to a turret supplier, usually more reactive. Either they want us to come and do an overdue inspection, or it's focused there's a problem or they need parts, and can we support them in that way? And any feedback and any data transfer to the design team has been very inefficient. So this is looking back. I've been in the mooring business now for about 26 years. And I'd say the first 10 years, 15 years, that's how we would see things happening most of the time. There were a few projects where we would actually see an operations team being an integral part of the project, and we would work with them on inspection and maintenance requirements as part of the design. And that's led to what we do now. So our focus today, along with that of MODEC, our parent company, and what we find across the industry, is really focusing, and I've switched gears a little bit, going to asset integrity and its management. But we focus on asset integrity not being an aftermarket support effort, but actually something we start from design and engineering, through procurement, fabrication, construction, making sure we have good as-built data, working through installation and commissioning, recording that data, and the feedback from operations gets back into our design and engineering. So that's our focus. And we see digitalization as a major tool to getting us to get these parts to work together and to empower the transfer of data and knowledge between the different phases. So if we look at a turret mooring system today, we're currently working on a project off the coast of Senegal, for example, and we have a very strong focus on digitalization. And these are typically a lot of the areas of the turret and of which we are monitoring. We've done this on a few other projects, but in this one, we're actually integrating it all, as I'll explain through the next few slides. So as you can see here, we're monitoring the structure, we're monitoring the mooring, we're monitoring the bearing to some degree. I'll talk about that as well. There's some process monitoring, but a lot of that flows straight through to the CCR. And we also ensure that as part of our monitoring system, we supply the DGPS sensors that allow us to track position, vessel heading, and also vessel motion. So we have MRUs on board the turret itself. All of this is integrated within our packages now. So we get all of our data through one source, one major source on the same timestamp. That's been one of our challenges in the past. We've had a lot of discrete instruments, primarily set up to send alarms to the control room. The rest of the data is lost, and none of that data gets back to the turret mooring design team. So this is our way of ensuring we get a full set of data that we can then use to help understand the performance of our system. So this chart shows what we're doing currently for this project. So we have a combination of mooring, bearing, and swivel monitoring, and we're actually got a data acquisition on board the turret that actually will process a lot of the data. And then we leverage the data link between the FPSO and the cloud to transfer data to which we have access in our offices or at any other location that we would want to have. So a lot of the pre-processing occurs on the turret equipment itself. That data is also sent to the through the ICSS to the central control room with the appropriate displays. We can feed some of the process data that's being monitored into our system as well. And a lot of our analytical models that we've developed to track trending and to help determine how the turret is performing in terms of rotation and breakout torque, etc., that will be performed on our cloud-based systems at the office. So just going through one example, and I'll go through a simple example of the mooring lines as to what we're doing. Typically, if we're monitoring angle as an example, this is an external turret. Measuring angle is a very robust way of monitoring the ankle leg health. That angle gives us some data that typically, if it was just an ankle leg monitoring system, we would focus on whether it stays in a green range or a red range. And that if it fell in the red range, it would provide us with an alarm. What we have now in most of our ankle leg monitoring systems is a way in which we take some more data from the vessel and we provide data we process the data on board the turret. We send the data to the vessel control room. And at that point, we can give some indications where we're tracking the data and we're providing a kind of a graphical look at, say, line tensions in a group of 4 legs at one corner of the turret, or one of the chain table. And that allows us to detect, and you can see here also with the color scheme, whether it's tracking within the expected range or whether it's falling out of it. The red dotted line is sort of the alarm limit. So this is what we've been doing now for the last 5 to 10 years. What we are doing now on this project off Senegal is we're actually collecting position, heading. If there's any environmental monitoring data from the vessel or surrounding systems, we collect that as well. We have a vessel monitoring, motion monitoring system. We get the loading conditions. We have the ankle leg monitoring system, as we said before. So now with the models that we have that replicate the performance of the mooring, we can get a prediction from external sources, the position monitoring, the vessel motions, the loading conditions, of what the tension and angle ranges, let's say angle ranges should be. And then from our ankle leg monitoring system, we get the actual data. And so what it allows us to do then is to start presenting information like this, where you can see that we still have one group of legs, which is in yellow, one leg in yellow that is identified as not being within the green zone. And it's made even clearer because you can see the prediction is showing us where it should be, and we're seeing and the yellow data shows us what we're actually measuring. This allows us to look, let's say if it's a deep water system, this could be that the polyester mooring has stretched a bit and that's changed the angle, and so that will give us some feedback that we may need to retension that particular mooring leg. So this is just one example. In other areas, we've always had to focus on visual inspections. Not everything is instrumented, especially on bearings. These are just some images of a new bearing installed and what it looks like maybe after several years in service. But on these bearings, everything's enclosed. It's very difficult to get quantitative measurements of bearing performance. So we are focusing now on providing some level of quantitative monitoring. So one way to determine if there's wear between the bearing surfaces is to monitor the relative elevation between the inner and outer race. And if you have as accurate as-built measurements, you can actually use that data to give you information if it's wearing. Of course, that's a very, very slow changing data. Typically, and we see very little wear, within the range of the accuracy of the measurement. But there has been one case where we've identified after 12 years of operation that we see 1.5 millimeters of wear, which allows us to monitor and look at other indicators. For example, grease sampling, that's commonly done on bearings and analysis, and I'll talk about that just a little bit. And we're also part of a joint industry project now that's looking at using acoustic emissions to detect early degradation of the bearing well in advance of maybe even what you'd find from the grease sample. What we're also doing as part of collecting this data and as part of our digitalization efforts is processing this data at a standard facility. So a lot of standardization, reporting the data on our intranet. So this data is now readily available to everyone in the company and also to the assets that we give access to. And you can track the data from all the previous samples, and we've actually developed small graphical indications of how things have changed over time. So this is one way of monitoring our system, and it doesn't seem like much, but in the past, samples would be taken, they'd be sent to different labs, the data would be provided in different formats, and most of the time it was never collected in a central repository. So this is just one of the many areas where we're saying, okay, we're digitizing the data that normally is kept on paper in the past. Another thing, and this is an area that I've actually been very focused on, is anchor leg mooring system component integrity. We actually now have a very large database of all the various assets that we collect data on over time. We've also had a very rigorous as-built program, so we know what the as-built dimensions of the chains were before they were installed. And we collect data and we analyze the data as we receive these measurements every 2 to 5 years on each asset. And again, available on our intranet as shown on this page. And this is then used in future designs. It gives everyone access, and we've got data now that's over 30 years old collected in this database. So what we're also doing is also trying to digitize our inspection. So we've developed software now that allows our inspectors to go in with a planned inspection plan that's developed by the asset integrity team before they go offshore. And they're able to collect data directly to a database, generate their reports. We're able to tag in pictures and videos. And all of this, the key thing, and I think the last point on this slide that we have here is feedback into our digital twin models. What we've seen a lot of is a lot of discussion of digital twins. And we've tried to focus on very specific areas where we want a digital model. But it's very important to ensure that that model is updated over time as we monitor the condition of the system, that we update those models to reflect the condition. Otherwise, we're just running a model based on the original theoretical data that we had when the asset was installed, and it may be diverging from what we're actually seeing offshore. So where are we going in the future? Some of what I've been talking about is what we are doing in the future. It's a year or two away, but we're working towards it. But what we are seeing in the industry and is a lot more use of AI to help, for example, with mooring leg inspection, detecting anomalies. We have begun, and I'll show you that in the next slide, in collecting data and collecting pictures of anomalies and storing it in databases. So this could be used by future AI tools to help with this automated anomaly detection. Predictive maintenance, I think MODEC has made a number of presentations on how predictive maintenance, how they've been able to utilize AI for predictive maintenance. And we are using a lot of the same models will be implemented on our system of Sangomar. The option for remote monitoring, leveraging the data links from the vessel. We provide that ability now to monitor various systems through our turret monitoring system. And we can see, especially as was mentioned by the last speaker as well, during the COVID period, this has been something that we've actually found quite useful. We've always had people going offshore, but we've actually been able to even do a swivel refurbishment to some degree, a seal replacement using Teams, for example, and so demonstrating that things can be done without having people there and training people on board the vessel to perform some of the tasks that would normally be done by someone coming over. So this has an impact on POB going into the future. So this is just one example that we're working with a few vendors on how we would collect data from our own systems. We have a number of systems and detect certain anomalies and then use this as part of an AI processing of the data that we do in future inspections to help pick out anomalies. A lot of these systems that we have in Brazil have about 75 kilometers of mooring lines on each facility. So using humans to go through and detect anomalies, there's quite a large risk of making errors. The problem is, of course, is that you have to still go through a number of the anomalies that it detects, but especially when it comes to anomalies today that are quite easy to capture. Let's say the picture on the left, the one that we say is moderate, where you can see around the weld zone, there's a clear level of corrosion where you can see where the weld took place on the chain link. Things like that we know today we're able to detect through these AI systems. So just some final thoughts. I've gone through this fairly quickly. I'm more than happy to take a lot of questions, but what we've seen is our current digitalization efforts have led to improved asset integrity management for ourselves. We find ourselves now being more of an asset, helping manage the asset and its integrity, rather than working through an aftermarket department where we're being asked to supply parts, or they want us to do a study based on data that's been collected. Even for our clients to which we've just supplied a turret, and let's say not MODEC, we are working with them and have arrangements where we are notified before inspections are made so that we can help plan and provide based on the previous inspection where the focus needs to be. But what we find today is that the focus is on adding value to the data that's acquired and its processing. We found that the transmission of data from the facility to the engineers and the support staff of the asset integrity team has been very efficient. The systems we have also give us ready access to data for all our assets. And the remote monitoring provides a lot of robustness. So what we do find now is that we get data, right now it's on a weekly basis, of the positions and some of the ankle leg tensions of some of our systems offshore. And we get a data dump every week, and we're able to go through that and compare it to what we've had in the past and detect if there's anything that requires a closer look. But I think one of the key things that the transmission of data, that what it's allowing and what we're seeing is it allows for design engineers and vendors to support remotely. This is something at least 10 years ago was quite challenging. And we're finding it obviously a lot easier to do now. What we see going forward and what we are doing already is using this to help with predictive maintenance, and then also help define a better risk-based inspection and maintenance program. And we're just on the cusp. I have to say that we're in the early stages of utilizing AI, but this is where we see, as it has been doing on the production side, we see this as helping us, especially on the load transfer side of the turret. But just a little warning, at least from my perspective, it can take us to some point, but we still need to understand that there's still a lot of condition monitoring that needs to be performed. Quantitative inspection, which today still requires quite a strong human interface. and trusting data that's coming remotely to your computer is only part of the picture. You must know the condition of the system for which you're receiving the data. I made this point before, but your digital twin or the numerical model that you're using to give you some indication on the, let's say, remaining life of some component, for example, that needs to be updated to reflect the current condition. And then the last point, don't disregard, that humans have a lot of experience and intelligence, and don't leave everything to the computers and AI models. Well, with that, I'd say thank you, and I'm more than happy to take any questions you may have.
Thanks, Arun. So, like the previous session, we will take about 2 to 3 questions from the audience. So, firstly, the adverse weather events seem to be getting more frequent and intense. Can the existing design standards or those implemented in the last 10 years in turret still adequate to address these trends?
So it's an interesting question because, yes, we have seen that there have been, and just as an example, in the Gulf of Mexico, 2005 to 2008, there were a large number of hurricanes that went through, and that changed all the design criteria that we have for systems in the Gulf of Mexico. The interesting thing that we're seeing, at least when I look at the turret mooring side, very few of the issues or failures, let's say of anchor leg failures or component failures or system failures, are driven by extreme weather. In fact, a lot of what we see is being driven by fatigue and being driven by corrosion, as an example. So I think the increase in the adverse events, those are being captured within the design criteria. And I don't think there's, as long as that design criteria, the design input is used with the current criteria, I think the turret is still adequate to do that, to handle these loads. Again, now if you're talking about a system that was designed 30 years ago and is now seeing a severe environment, that would need to be evaluated, and that's commonly done. We have done that where, especially when during life extension, we would consider the impact, the current condition, and the impact of the change in environment. So hopefully that answers your question.
Thanks. So we got 2 questions on external power. We will do the one on the challenges first. So what are the major issues that need to be overcome in order for external power sources to the FPSO through turret? When do you foresee the new technology will be matured enough to overcome this?
So really, for power to shore, what you really need, again, because you have a geostationary cable bringing power to a weather vaning FPSO, you really need to be able to transfer that through a power swivel. And currently, power swivels in operation are typically handling about 30, maybe a maximum of 30 to 50 megawatts, let me say. If we want to transfer data at a much higher voltage, let's say 125 kV, that requires a more robust and a larger high voltage swivel design, which has actually been done at lab scale and has been done to prove the concept. And we have actually worked quite closely with 2 suppliers on developing power swivels that can transfer up to 200 megawatts through a high voltage swivel. We've already completed an approval in principle with DNV for both its implementation on the turret as well as the design of the swivel itself. It just requires some funding and the building of the first prototype. So in my opinion, the technology is there. It does require, to be built as a prototype and be tested, but I don't think we're more than, I think when MODEC was looking at power to shore, that's where we focused on developing the swivel technology. And we felt we were 24 months from delivery of such a swivel.
Okay, and the next and the last question, also on external power. What is your view on the additional turret capex needed for the turret FPSO to accommodate power from shore?
So as I mentioned, the focus is primarily on the swivel, and the cost of the swivel. So that by itself, I would say, if it's a complex turret, and again, turrets range in price from, I'd say, anywhere from 20 to 30 million to 300 to 500 million, depending on what's in your turret and what you're trying to do. The swivel component is not a very large component of the turret price, so I don't see it having a major impact. What you do have to be careful about is that you are now running high voltage and running it through a production system, because the high voltage lines would be running through the production swivels on the interior. So there's a lots of proximity to gas, if it is a gas field, for example. So that's just something that needs to be considered. But as part of our approval in principle with DNV, we were looking at this swivel and the turret was designed to have power with gas. So I don't see it being a major CapEx issue, but it will be an additional cost for sure. And it may grow the size of the turret because of the space required for the cabling, and just from a safety perspective as well.
Thanks, Arun. Thanks for being here with us.
Okay, I appreciate it. Hopefully next year I can be there in person.
Yeah. Okay, I'll now hand back to Jamie, who will bring us for lunch.